Hello all and welcome to this third video on basics of matrices, and in this we'll look at matrix multiplication. As you can see, there's this animation running and it'll just keep repeating, so I'll go and start talking about in a minute what's actually going on. But as I was just saying, we're doing matrix multiplication, so we're multiplying one matrix by another. Now, as you're probably starting to see, there's a fair bit going on here. It's a tedious process. Doing it by hand is without a doubt tedious, especially as matrices get larger and larger. There's a lot more going on. But you do need to understand what is going on physically with basic matrix multiplication, so that when you apply this to much larger matrices using a calculator, you know what an expected result is going to be. So let's jump in and take a look. Matrix multiplication can be summarized as follows. Multiply the rows of the first matrix by the columns of the second matrix. That's essentially what is happening. We take a row of the first matrix, multiply it by a column of the second matrix. Another way that can be thought of it is the first row is bus parking into the space of a second matrix. So what I mean by that is taking this row, it's getting reversed into this space here. So that's what we're doing as a multiplication. So we can see we take the 1 and 2, and we'll just look at this first row in this first column. We take the 1 and the 2, and we're going to multiply them by the 5 and the 7. So we get the 1 times by the 5 there, so that by that, and then the 2 by the 7 there. And then each of those two numbers that we've done the multiplications of, whatever we're going to get, we get a 5 and a 14, we're going to add them together. Okay? And then we just keep repeating that process over and over. So it's sort of like every row needs to be multiplied by every column. It's a bit like that idea of a binomial expansion, where if we have A, B, C, D, you have to do A by C and A by D, and then B by C, B by D. You had to multiply everything by everything. Well, that's going to be the same in this case. You have to multiply each row by every column, and every column by every row. So there's a breakdown of it. Now, I think these animations are well and good, and some people like them, but I think me going through a actual worked example straight off the bat will make this a little bit easier. So let's say we've got matrix A is equal to 2, 3, 4, 5, and we've got matrix B is equal to 1, 2, 3, let's go 6. Okay, and we're going to do A times B. Now, order is important. This is where multiplication is different to integer multiplication, but matrix multiplication, the order is important because you always use the rows of the first column and the rows of the first matrix and columns of the second. So let's just write this out as it is. 4, 5, 1, 2, 3, 6. Okay. Now, first things first is what is going to be the resulting size of this matrix, because depending on the sizes of the starting matrices, the end result will be different. The way to figure this out, and this is the layout that I've always used and always suggest, sorry, I'm going to sneeze here, pardon me, is write the order. So that's a 2 by 2, and in this case this is also a 2 by 2. And then you look at the outside numbers. Look at the outside numbers, and that's going to be your result. In this case, it also happens to be a 2 by 2, and that's why we started with this, because it's nice, easy, straightforward. So I'm going to draw a quite spread out 2 by 2, but it's going to be a 2 by 2, and we're going to have this position here, this position here, this position here, this position here that we're going to need to fill. Let's go 2 by 2. I'm going to 1, 2, 1, 2. Now, it's fairly straightforward for a 2 by 2 not to get confused on what rows and what matrices, what rows and what columns to be using. But this is a great tool that we may as well start using straight away, is putting this 1 and 2 above and beside both the rows and the columns. And then, so if I want to fill this box here, I need to use, well, row 1 here, and I need to use column 1 here. So I'm going to be using row 1, and let's change these to green, make this a little bit easier. And then because I need to use column 1, so I'm going to use column 1 there. So that's what I'm going to have to multiply together. Take the row of the first, and the column of the second matrix. So I'm going to get the 2 by 1, and then I'm also going to have the 3 times by the 3. So I've multiplied the 2 by the 1 and the 3 by the 3. And that's my first spot filled, and I need to add those two together. We'll put that in here. So that first spot becomes 2 plus 9, which will become 11. Now I can pick any one of these spots in my, I'll call this the answer matrix. I can pick any one of these spots here. Let's pick this one top right. Okay. Now that has the green 1. This spot here is green 1, red 2. So that means I need to use row 1 and I need to use column 2. So I'm going to be using row 1 again, but this time I'm going to be using column 2. And I'm going to do the same process. I'm going to multiply each number together and then add them. So I'll do it again in the color code just to be clear. So we get 2 by, and we're also going to have by 2, and then I'm going to have the 3 times by the 6. And again, those two bits I add together. Okay, so in this case, I've done the 2 by the 2 and the 3 by the 6. And with these rows and columns, when we're using them, we always work left to right through the row, and then we work up to down, moving downwards of the column. So we couldn't do 2 by the 6 and then the 3 by the 2. We can't do that. You need to start at the left and you need to start at the top and work your way down. So that's filling that top position. 2 by 2 is 4, and we get plus 3 by 16 is plus 18. So that's going to be 22 in the top right position. And then we just keep repeating this process over and over. So we'll do the bottom left. So here we can see I now need to use row 2, and then I'm going back to column 1. So I'm going to get 4 by 2 plus 5 by 6. So that becomes 8 plus 30, so I'm going to get 38. And then finally, bottom right, I'm going to be using row 2 and then column 2, so I'm going to use row 2, column 2. So that becomes 4 by 2 plus 5 by 6. So what have I done? I've made a mistake back here. I was looking at the wrong numbers. I was going to say, why is that the same? My apologies. Okay. Looking the wrong side of the line. Let's go back. That was 4 by 1 it needed to be, because we're taking row 2 by column 1, plus 5 by 3. Much better. So that becomes 4 plus 15, that becomes 19. My apologies there if that really lost you. Now 4 by 2 is 8 plus 30, that gives me 38. And that's our answer. So you're taking every row of the first matrix and multiplying it by every row of the second matrix. Now, here is a great video. I'm not going to play it, but great video by Khan Academy. If you haven't heard of Khan Academy, it's an incredible YouTube channel. It has pretty much everything. It's a bit more segmented. Sometimes they don't explain as much background or terminology, but there's a video there that also walks through how to do it. Here is another way that you can visualize it. Again, you're holding out your fingers, matching them up to the corresponding correct row and column, and then working through as needed. But again, you can load that up on the PowerPoint and have a look at that animation. I'll let it just finish playing through this last time. There you go. Right. So back here, we looked at writing the orders of the two matrices on top. not only, and that's useful for finding, if you look at the outside numbers, so the 2 at the far left and the 2 at the far right, that tells us what the final answer is going to be. It is also, writing those orders on top, really useful to identify, are you even able to do the multiplication? So in this case, this first matrix is a 3 by 2 and the second matrix is a 2 by 4. Well, if we look at the outside numbers, so the 3 and the 4, that means my answer will be a 3 by 4 matrix. So it's going to be that. Okay, so we have 1, 2, 3, 1, 2, 3, 4. So it's going to be quite a large matrix. That's going to be the answer. But will we actually be able to do that? Will we be able to make that 3 by 4, or will it actually exist? Is you need to look at these inside numbers, and these need to match to be able to actually do the multiplication. Because if they don't match, let's say this was a 3 by 3 instead, as a counter example, and we put 1, 4, 5 in here, we run into an issue. As we take this row and multiply it by this column, well, we get the 1 by 2, which works. We get the 2 by -1, and because this is only has 2 rows, it doesn't have a third row to match this 3. This 1 here has nothing to multiply by. Has absolutely nothing. It's not even 0. It's just a nothingness. So you can't do it. You can't do it. So what this is technically saying, when we say that these inside numbers need to match, what it is saying is the number of columns of the first matrix must match the number of rows of the second. Those two need to match, because there is going to be 2 columns that are going to get multiplied by 2 rows over here. So that's how we can check if an answer will exist. Now, if you're asked to multiply, maybe you're asked to multiply a 3 by 3 by a 2 by 3, and you're asked to do that, straight away you can see, okay, that number and that number don't match. So you can instantly say not possible or no solution. You don't have to attempt anything. That's all you need to write. Okay, so that determines if we can do the multiplication, and then the outside numbers determine what's going to be the final size. And we can see, we do the process over and over. That gives us our first line. And that gives us our second row, and then our third row. Those numbers are generated that way. As I said here, doesn't match, so we can't do it for the reasons previously explained. Because again, if I try to take this row and multiply it by this column, well, 2 by 1 is fine, 3 by -1 is fine, 1 by 1 is fine, but this final one has nothing. We can't do it. Right, with this too, just quickly here, this means order is important. Because if we flip this scenario, say we call this A and we call this B, well, A times B is not possible. But if I did B times A, switch the order, I've now got a 3 by 2 times by a 2 by 4. Since the inside numbers match, that one is actually possible. We could do that. So order is critical for matrix multiplications. Rightio. So let's do some examples. Determine whether or not the following matrix is able to occur, and if so, carry them out. Well, A by B. So this is a 3 by 2, and B is a 2 by 1. Okay, so I'm doing a 3 by 2 by 2 by 1. Inside match, so it gives me a tick, and that means my answer is going to be a 3 by 1. So 1, 2, 3. It's going to be 1 across. Okay, so I'm going to be taking, let's do this top spot, that's first row, first column. So I get 5 by 8 is 40, plus 2 by 9 is 18. The second spot, I'm going to do second row by first column. That's what I'm using this code. Second row, first column. That tells me what I need to multiply together. So I get 4 by 8 is 32, plus 6 by, that's 9. 6 nines I can get my brain to work, 9 sixes would be 54. And then finally, third row by first column. So 1 by 8 is 8, plus 3 by 9 is 27. So that's going to equal 40 plus 18 is 58, 32 plus 54 is 86, and 8 plus 27 is 35. Yes, 35. So that's the first one. C times D, well, C is a 1 by 3, and D is a 3 by 1. So I'm doing 1 by 3 times by 3 by 1. Inside numbers match up. Outside numbers tell me what the result is. So this is just going to be a 1 by 1. I'm going to need a bit of space, though, to do this. So 1 row, 1 column, that's all it is. So I need to do 2 times 8, which is 16, plus the 4 by 6 is 24, plus the 7 by 5 is 35. So that is equal to 16 and 24 is 40, plus 35 is 75. That's all it results to. B times A, well, that's asking me to do a 2 by 1 times by a 3 by 2. Inside numbers don't match, so it is not possible. No solution. D times C, that's asking me to do a 3 by 1 times by a 1 by 3. That matches up, so I can do it, and this is going to result in a 3 by 3. So that's going to be quite large. 1, 2, 3, 1, 2, 3. Okay, I'm going to rewrite what this actual problem is in order just over here beside it, so I'm not going to get confused. 2, 4, 7. Okay, top left, first row by first column, 8 by 2, that's going to be 16. Next spot, first row by second column, so first row by second column is 8 by 4, so that is 32. And then this spot is first row by third column, so that is going to be 8 times 7, 56. Okay. I go to a different color, so now I'm on to this spot, which is second row by first column. So second row by first column is 6 by 2 is 12. Next one is second row by second column. So second row, second column is 6 by 4 is 24. Next spot is second row, third column. So 6 by 7 is, oh god, mental math is not working at the moment. 6 sixes is 36 plus another 6 is 42. And now finally we're on to third row, first column, third row, first column. 5 by 2 is 10. Next spot is third row by second column. So 5 by 4 is 20. And last but not least, third row, third column is 5 by 7 is 35. And there's our answer. So yeah, a fair bit in it. Here's an applied problem example. And this is the first matrix shows the number of cars and bicycles owned by two families. The second matrix records the amount of wheels and seats that are on cars and bicycles. Find the product of the two matrices and interpret the result. Okay, so we're going to do this first matrix. Let's call this A and this B. So we're going to be doing A by B. And this is a 2 by 2 and this is a 2 by 2. So the middles match, so we can do that. And the outside tells me what side it's going to be. So we're going to get a 2 by 2. So let's draw that with some space. 1, 2, 1, 2. Okay. So top left, first row by first column. So we've got 2 by 4 is 8 plus the 3 by 2 is 6. We've got, let's do top right. We've got first row by second column, so we're going to do that by that. So we've got 2 by 5 is 10, plus 3 by 1 is 3. And move on to the other two spots. Let's do these in black. So we've got second row by first column is 1 by 4 is 4, plus 4 by 2 is 8. And then we've got second row by second column. So we get 1 by 5 is 5, plus 4. This gives me 8 plus 6 is 14, 10 plus 3 is 13, 4 plus 8 is 12, and 5 plus 4 is 9. Okay, so what is this matrix telling us? Well, let's think about what we were multiplying together. In the very top left, we were multiplying these numbers here by these numbers here. That was just to give us the top left. Gave us this number here, the 8 plus the 16. So we've got Smith having 2 cars and also having 3 bicycles multiplied by this column, which told us that the car has 4 wheels and a bicycle has 2 wheels. So we've actually multiplied the number of cars by how many wheels are on it, and we've multiplied how many bicycles the Smith have by how many wheels are on a bicycle. So in essence, this number here was all the Smith items, so how many cars and how many bicycles multiplied by how many wheels each of them have, times by wheels, so it is the number of wheels that the Smiths have. That's what that is. And then if we repeated that process over for looking at the top right, what we did to get this 10 plus 3, which was 13, well, we took first row, which is again the Smith items, but we were multiplying it by this column, which was the number of seats. So we did 2 by 2 cars, which each have 5 seats. We did the 2 times 5, which is 10, and then we had the 3 bicycles times by 1, because they have only 1 seat each, which means that here is, again, the Smith family, how many seats they have. So we could say that this is Smith, and this is wheels, and this is seats. And if we apply that process over, you'll realize that this is Jones. So we can see how many wheels the Smith family have, how many seats they have, how many wheels the Jones family have, and how many seats they have. That's really handy. We've taken 2 individual sets of data and multiplied them together and gave us another new set of data as some new information about what's going on in this scenario. Instead of having to look at, okay, I've got Smith cars multiplied by the wheels, figuring out what this final matrix means, the easiest way to identify what it actually means is, because you're taking the rows, you're going to keep the row names. Keep the rows of the first. And then because we're taking the columns, we're going to keep the column names of the second matrix. That's what the resulting matrix actually is. Now, to be able to do that, and this is where this inside bit has to match, is not only were these matching in size, they were actually the same thing. Okay? The columns of the first were the same as the rows of the second. Column, row. Column names match the row names of the second matrix. That's what allowed us to do that multiplication. Not only were they the same size, but in an applied problem, they have to be the same name. So that's how to use an applied problem. There's a bit there to wrap your head around. I have less concern at the moment about you being able to do the applied problems. There are certainly some practice ones in the worksheets, but our main focus is on just being able to do the multiplications first. Last but not least, as already shown, we can store matrices in our CAS. This is how we can do the multiplication of them. So I already had A and B stored from the previous video up here. There's where I stored A and B, and I can quite easily just go A, and I can put times by B. Oh, I need to do capital A. That's what the matrix is called. Capital A and little b are different. And there we go. It's done it for me. And I could do B times by A, and I'll get a different result because the order that we do them in is important. That is it for matrix multiplication. You now need to do exercise 26C part 1 and exercise 26C part 2. Hope you have a good evening. If you have any questions, feel free to ask. As I said earlier in the video, there's that Khan Academy video. If you need extra ways of seeing it done, there's plenty on YouTube. But if you have questions, put it below or in Google Classroom or shoot me an email. See ya.